Hi, welcome to the final video for topic 2 in Year 11 chemistry. This one's going to be looking at quantities of molecules and ions. So this will build on a little bit from topic 1 where we introduced stoichiometry and we looked at number of moles equals mass over molar mass, and we started doing a couple of calculations there. So we're going to look into that a little bit more. So you've got to remember stoichiometry is the calculation of amount of reactants and products in a chemical reaction. And the important thing to remember is what's called the law of conservation of mass. So there has to be balance, all right? Matter cannot be created or destroyed. It can only be converted into other forms. What that means is that if you have 10 kilograms of reactants at the beginning, you must have 10 kilograms of stuff at the end. Now notice I didn't say products because normally not everything always gets converted into products, and that's the idea of sometimes equilibrium reactions, which we'll look at a bit later. But at the end, you must end up with that 10 kilos if you had 10 kilos to start with. Now, it might be that some of that is a gas which has escaped into the atmosphere, right? But there's still 10 kilos at the end as there was at the beginning. So that's really important, and that's why we can do these sorts of calculations, all right? So, quick refresher, all right? Number of moles is birds over mountains. So you're going to need to be familiar again with how you calculate number of moles using this, how to calculate the mass of a substance, and also to have your scientific notation down pat, okay? So please make sure if you need a refresher on that, you look at any of these videos. So scientific notation is that one, okay? Mass of a substance is this one. Calculating number of moles is this one. Again, if any of you want a copy of this PowerPoint, or so that's got the actual links in there directly. In the first video at the beginning, I share my email, or you can put a comment down the bottom if you want, asking for a copy of this as well. So when we go into stoichiometry calculations, in the past we just did very, very basic ones. Now what we're going to be looking at is following some steps when we start with some reactants, working out how much we've got in terms of products. So if you follow these steps, you'll get some success. All right. So, and it doesn't matter what reaction you're looking at. Okay, it's the same steps every time. So make sure you have the correct balanced equation. So that really is the most important part of this, and that's why I hammer with my students as well right at the beginning around balancing equations and being able to write formulae. They're two key things. If you can't get that right, you're not going to be able to get your calculations right. Okay. Then the next thing I encourage them to do is to write down what you know from the question. So actually have a look at the question, work out, is it giving you the mass? Is it giving you the number of moles? You can always work out the molar mass of something, so write that in as well. Then calculate the number of moles for what you know. So I call that the known. Okay, so the known is something that you'll have two values for. You'll always have the molar mass, and then the question will give you either the number of moles or the mass. Okay, so you'll have two things that you know. That's your known. It'll ask you to work something out, and you won't have two values for that. So that's how you work out which one's known. Then you work out what we call the mole ratio. So that's where your balanced equation is really important. I'll show you that in the next step. Always do unknown over known, okay? Because then what that allows you to do for step 5 is just simply calculate, so it's to multiply step 3 by step 4. Then you can calculate the answer. So you might want to write these down, have a little screenshot of this something as I go through the examples and you see how I follow each of the steps. So here we go. If we've got 10 grams of sodium metal, we drop it into a beaker of water, which is a really cool reaction, what mass of hydrogen gas would be produced? Okay, so step 1, balanced equation. So you can see here, we've got our balanced equation. It's really important that you get that right. Okay, so 2 moles of sodium with 2 moles of water gives us 2 moles of sodium hydroxide and 1 mole of hydrogen gas. Then we write down what we know. So up here in the question, it said we have 10 grams of sodium. So we put mass of sodium is 10 grams. We can get the molar mass off the periodic table. We're trying to work out the mass of hydrogen, and so we can get the molar mass of hydrogen as well. So this is just what we know. All of that is from the question up here. Then we calculate number of moles of what we know. Now the known was what we had two values for, which is that one there. So it's birds over mountains, mass over molar mass, and we get a value of 0.435 moles. So hopefully I've tried to color code this so you can see how the colors keep following. So 10 to 10 and 22.99 and 20.99. So I've tried to follow it through. Okay. Then we do the mole ratio. So the mole ratio is something that some people find a little bit hard to get their head around to begin with. But we're doing our unknown over known. So we worked out that our unknown that we're trying to work out is the H2, and the known was the sodium metal. So we're going to do hydrogen over sodium. So having a look at the equation up here, in front of the hydrogen is a 1. It's not written, but that's what's there. In front of the sodium is a 2. And so that's why we get a ratio of 1 over 2 from the equation above. Then for step 5, this is calculating the number of moles of your unknown. So it's number of moles times mole ratio here. So it's just step 3 times step 4. So we got this half value here, and we're multiplying that by the value we got up here for the number of moles. All right, so we get 0.217. So that's where your understanding of the mole ratio of a reaction is really important. One thing I will say here, don't round off your calculator. If you round, you end up getting errors carried through. Okay, so it's important you just leave the value. So if you look on your calculator, you get a bigger value than this. I've just written it there to 3 decimals, but you keep your value on your calculator. The final step is to work out what the question is asking you. And the question up here was asking us to calculate the mass. All right, so mass is number of moles times molar mass. So we take the number of moles here that we discovered, 0.217, we multiply it by the molar mass that we found out up here, and we get 0.438 grams of hydrogen gas. So 10 grams of sodium actually gives us a very small amount of hydrogen gas. Hopefully you've worked out the reason for that though, is that hydrogen gas has a mass which is about 10 times less than that of sodium metal. And in the mole ratio, we've got half again. So when you've got 10 times less, right, that will take it from 10 grams down to 1 gram, and then the ratio is actually half again, so it's down to about 0.5, which is what you'd expect. Okay, so we're only producing about just under 0.5 grams of hydrogen gas. That's still enough though to create really, really impressive. If you had 10 grams of sodium, that's a really impressive amount of hydrogen that would be produced that could be ignited and produce a good size explosion. Do it again. What mass of oxygen will be required to completely burn 2 kilograms of methane gas? So again, step 1, you need your balanced equation. So here's our balanced equation of methane plus oxygen to give carbon dioxide and water. Step 2 is writing down, sorry, I've just got a really itchy nose today. Step 2 is writing down what we know. So up here, we've got 2 kilograms of methane gas. Now, anytime we've been doing these calculations, all right, mass has been in grams, all right? So we need to do a conversion. So 2 kilograms becomes 2,000 grams. So you've got to make sure you get your conversions right. The molar mass of methane we can get off the periodic table is 16.042, and we can work out the molar mass of oxygen as well. Now, because methane is what we've got 2 values for, we've got the molar mass and we've got the mass, all right? That is unknown. So that means we're going to calculate the number of moles of that. So 2,000 over 16.042 gives us 124.5 moles of methane. Getting the mole ratio from the equation, the oxygen has a 2 in front of it, the methane has a 1 in front of it. So the ratio is 2 over 1. Okay. So now for step 5, we multiply the mole ratio here, 2 over 1, by the number of moles that we had from the previous step here. That gives us 249.35 moles of, this should say oxygen here, not H2. I just copied that over very badly from the last slide, sorry. So that should say O2 and O2 there. So the mole ratio, so number of moles of oxygen is 249.35. So we then work out the mass, which is what the question is asking us to. What mass of oxygen should we have? So it's number of moles, the red one here, times by the molar mass, which we worked out up the top here, okay, to give us 7,978.58 grams. Now, because the question said kilograms, we're going to convert this into kilograms as well. So 7.98 kilograms of oxygen gas would be needed. All right. Got one for you here. If some ammonia gas and hydrochloric acid reacted to form 2.5 grams of ammonium chloride, what mass of ammonia gas must have been used to start with? So I suggest you just pause it here, okay, and try and work this out. And now I'm going to go through and show you. All right, so step 1, I'm just going to change pen colors here, sorry. Step 1 is to do a balanced equation. So we've got ammonia gas, NH3, and we've got hydrochloric acid, which is HCl, and that forms ammonium chloride. Now, this is actually an equilibrium reaction, but I'm not going to introduce equilibrium just yet, okay? But this is, so you might see this sometimes with double arrows in between if you Googled the equation, okay? But this is the reaction that we're looking at, and the great thing about this one is it's actually already balanced. We've got 4 hydrogens on each side, 1 nitrogen, 1 chlorine, so it's really nice. Then we do what we know. Okay, so from the equation, we've got the mass of ammonium chloride is 2.5 grams. We can work out the molar mass of ammonium chloride. So I'm just quickly going to do this on the calculator here, sorry. So roughly, and I'm not checking this, sorry, so I'm just doing it off the top of my head. So 53.492, hopefully I've got that right. All right, so that's grams per mole. And the question is asking us to work out what mass of ammonia gas. So we want to work out molar mass of ammonia. All right, so that's going to be 17.034 grams per mole. So that's working out what we know. So writing down what we know. Now we're going to do number of moles of our known. What we've got the known for is ammonium chloride. So we're going to try and work out the number of moles of ammonium chloride. So that's mass over molar mass, birds over mountains. So it's 2.5 over 53.492. So that gives us 0.041 moles of ammonium chloride. The mole ratio is number of moles of ammonia. That's what we're trying to work out over number of moles of ammonium chloride. So from the equation, that's 1 over 1. So what's really good about that is that for step 5, the number of moles of ammonia is just 1 over 1 times by 0.041. So it's still going to be exactly the same number of moles. So then for part 6, we can work out what the question's asking us, which is the mass of ammonia, which is number of moles times molar mass. So it's 0.041 times by the molar mass that we worked out up here, 17.034. Again, we didn't round off on our calculator. Okay, and we get 0.7 grams of ammonia. Okay, so hopefully that matches what you guys got. All right, if not, go back and have a look, compare my values to what you've done. If it's very slightly different because you just use slightly different molar masses off the periodic table, so atomic masses off the periodic table, that's fine as long as you've got an answer that's pretty close to points. All right, so I shared this in the last video, and I'll share this in the last topic, I should say, and I'll share again in this one. Practice makes perfect, okay? Or if you want to do it as Yoda, perfect, practice makes. All right, there's no substitute for it. There's more examples here in this YouTube video that you can have a look at here. So there's the link if you can't find it on my video channel straight away. But it goes through quite a few calculations, and I really encourage you to have a look at that. Practice and practice and practice them as much as you can, and you'll be fine. So the good news is that's the end of this topic. All right. Hopefully I'll see you for the next topic, which for my students will be acids and bases. As always, if you've got any questions, just ask. And to everyone, thank you so much for your support and for watching these videos. I really hope they're useful. If there's anything that you want me to explain that you can't find a video on, please just post a comment below, and I'll try and get up for you as soon as I can. Thanks everyone. See ya. This is real love. This is real love.